main groups: the monotremes, or the egg-laying mammals, the placental mammals, which are the vast majority, and these include animals such as humans and whales and giraffes. And then you have the non-placental mammals, or the marsupials. The placental mammals and the marsupials differentiated from each other around 100 million years ago, with the biggest difference between the two groups being their reproductive systems. Both of these groups of mammals managed to spread across the globe, but the marsupials were often outcompeted by the placental mammals. This meant that there was a far greater number of placental mammal species compared to the marsupials, who were far less species rich. This competition limited marsupial evolution to just small possum-like creatures, and they weren't able to evolve into any large animals, as those niches were filled by other, more successful groups. Now, around 65 million years ago, the marsupials had spread to and had large populations on the landmass which is currently South America, with current American marsupials including animals such as the possum. Around 50 million years ago, a few species of these marsupials migrated across the gap which was forming between South America and Antarctica, and they reached the landmass which formed Australia. This bit of land then split off and became very, very isolated. Historically, the placental mammals were more successful than the marsupials. This allowed them to become the dominant mammal species around the globe. However, Australia didn't have any placental mammals on it by the time it drifted away from the mainland. Isolation and a lack of competition leads to adaptive radiation, which is exactly what happened to the marsupials and led to the evolution of some incredible megafauna. Adaptive radiation is when a small group of animals radiates into many new species due to an abundance of new food sources and niches. In this situation, the first marsupials to arrive in Australia were probably generalists resembling possum-like creatures. The lack of any other mammals in Australia meant that there was a vast range of food sources not being utilised. These first generalist marsupials could start exploiting these food sources and evolve new characteristics to better exploit the niches. For example, one part of the population could start eating more fruit and evolved features to make fruit eating easier and easier, eventually forming a brand new species. Another section could take advantage of the grasslands available and evolve distinctive characteristics to take advantage of that niche, again forming a new species. This happened many times over for a huge range of niches, and marsupials were able to exploit many of the food sources available, forming many new species. With adaptive radiation often comes convergent evolution. This is a process where different unrelated animals evolve the same features and characteristics as each other to overcome similar problems and niches. A really easy example of this is the evolution of flight, with birds and bats both evolving this method of locomotion despite being very distantly related. The marsupials that evolved in Australia showed a number of cases of convergent evolution, with the fauna there evolving very similar traits and characteristics to the megafauna currently living in Africa. The resulting Australian megafauna were incredible beasts to behold, dominating the landscape and providing a rich and varied ecosystem. Our first example of Australian megafauna is the giant diprotodon. This is the largest marsupial to have ever lived. At 3 meters long, 2 meters tall, and weighing nearly 3 tons, this animal is very closely related to and resembles a giant wombat, with very similar dimensions to a hippo, but closely resembling a rhino without a horn. It fills similar ecological niches as a rhino too, largely grazing and browsing near waterholes. But as a marsupial, the mothers had a large pouch to keep their premature young safe. It walked alongside humans and is still present in Aboriginal folklore, maybe being part of the inspiration for the mythical bunyip, with Aboriginal tribes claiming that the diprotodon bones they have collected belonged to these mythical creatures. However, diprotodon became extinct around 45,000 years ago, a time period that will